Hi, welcome to the chemical reactions tutorial series. This is actually, even though there's 4 objectives, one of the content assessments for the year that has the least amount of content. So that doesn't necessarily mean it's going to be easy for everybody, but we only have to talk about 4 different things. First, what is a chemical versus physical change and what does it have to do with chemical reactions? What is happening during a chemical reaction? Then second, we were going to talk about the parts of the chemical reaction, the reactants and the products, and also learn how to read a chemical equation with its coefficients and subscripts. Finally, we're going to talk about the law of conservation of mass and what that has to do with chemical reactions. And lastly, we're going to talk about exothermic and endothermic reactions. So looking at chemical reactions in terms of the energy. And this first video is going to be focusing on just what are different kinds of chemical reactions and the difference between physical and chemical change. So let's start right there. You may have learned this already in this year if you already did the Earth Materials and Systems. We talked about chemical versus physical change there. In structures and properties of matter, we talked about physical characteristics and chemical characteristics. So these related concepts have already been covered earlier in the year. But a chemical change is any time that a change alters the composition of matter. That means bonds are broken or formed and new chemicals come out of it. There's new substances being produced. So rusting, burning, chemical reactions, cooking are all examples of that because you make new things out of it. Then you have physical change, and those are the changes that do not alter the chemical composition of matter. You end up with the same chemical before as after, but they may change in the appearance or the way they act, but not because it's a new substance. It's still the same substance. Like when you melt or boil water, it's still water, before and after. You may have frozen water or liquid water or gaseous water, but it's all water, so it changes in state. Changes like changing the color or changing the shape or breaking it apart. So here's some more examples of that, right? So melting ice, shredding paper, chopping wood, mixing things, all of that would be considered a physical change. But if you burn wood or something rots or fireworks, explosions, chemical reactions, baking soda mixed with vinegar, all of those things would be considered chemical change. So there are different kinds of reactions that we have to be able to recognize. But before we talked about that, we have to remember that what a key thing about chemical reactions is that no matter how you look at it, no matter the type that you look at, there's always going to be bonds being broken and bonds being formed. Like here, you see how a bond forms between A and B, and here a bond breaks. Here, the bonds change places. A and B used to be together, and now it's A and C that are together. So you have to break and form new bonds, right? So the key thing is that there are always new substances that form. So right here is a compound that's made up of A and B. Right here, you have A by itself and B by itself. So you go from a compound to an element and so forth. So each of these things is showing that you can break and make new bonds to form new substances. Now, what happens to the properties of substance during these reactions? Well, they have brand new properties. For example, when you get a little bit of oxygen gas and twice as much hydrogen gas, and you burn them together, you suddenly make an explosion that produces water. Now, those two things used to be gases. You have a hydrogen-filled balloon in an oxygen atmosphere, right? And then when they combine to make water vapor, well, water and hydrogen and oxygen are very different from each other. Oxygen would accelerate a flame. Hydrogen would actually explode, and water will put out a flame, right? So they have very different characteristics. And in fact, at room temperature, water is going to be a liquid, while hydrogen and oxygen are going to be gases at room temperature. So you can go from two elements to make a compound, and the characteristics of the compound will be completely different, both physically and chemically, from the pieces that made it up. So that's what happens during a chemical reaction. The chemical and physical characteristics change. There are some things that can tell us that chemical reactions are taking place. Like, for example, a lot of times when the chemical reaction takes place, you get a production of heat or light. You get a gas can form. You can have a formation of a precipitate, which is when two things mix and then something kind of falls out of solution, and you can see the salt forming in the bottom or precipitate forming in the bottom. Could be color changes, and it can even be a production of a new odor that has something to do with the gas that's being formed. Now, it's important to note that all of these things by themselves are not enough to tell you that it is a chemical reaction. After all, we can flip a light switch and a light will go on, and that's not necessarily a chemical reaction taking place, but it is production of light. You can form a gas by evaporating water, and that's not necessarily a chemical reaction. A precipitate can form when a substance is supersaturated, and you put just one more drop of salt, and all of a sudden, the entire solution falls out of solution. A lot of the salt would. So that's not a chemical reaction. You could have a color change by just painting something or putting food dye on it and mixing with the water. And you can have a production of an odor that doesn't necessarily mean there could be a gas leak. It doesn't necessarily mean a chemical reaction is taking place. So each of these things by themselves is not enough, but usually when a chemical reaction takes place, one of these things will usually take place. Now, there are different types of chemical reactions I would like to talk about. First one is this idea of synthesis, and that's when two chemicals get put together. Then there's the idea of the opposite, which is decomposition, which is when the chemicals are broken apart. So you used to have them together and they get separated. Then you have single replacement. And that, I think of that as like a dance where one partner switches places with the one that's alone. So in this case, you have A and B and then C by itself, but then they trade places. The B and the C did. And then there's double replacement when there's a two switcheroo and two chemicals will switch places. But again, what they all have in common is that bonds are being broken or formed and new substances are being created. There's also the famous combustion. Combustion is basically what's going to happen. It's a kind of special double replacement where you have a piece of fuel that burns in the presence of oxygen. So it's an oxidation reaction. And then it forms carbon dioxide and water. So generally you have a fuel plus oxygen with a source of heat creating combustion that makes an exhaust, which is usually carbon dioxide and water, right? And then that same heat that's forming the combustion will feed back and refeed the cycle and keep the fire going, right? That's what's so special about combustion. Once it starts, as long as it doesn't run out of fuel or it doesn't run out of oxygen, it will keep going. Now, that doesn't necessarily mean the product will burn completely, and that's why sometimes we have ashes. But if it is a complete burn, you will usually have carbon dioxide and water being made. And that's pretty much it for the first objective. On the next one, we're going to talk about what are the parts of a chemical reaction, and I'll see you guys then.